Hey, what's going on, guys? Let's answer these questions right here. So the first question is asking, define the resultant hydrostatic force acting on a submerged surface and the center of pressure. So first of all, let's define what hydrostatic force is. Hydrostatic force is basically the force that is created by pressure. So the resultant force of the pressures, that's what we call hydrostatic force. And the center of pressure is the location this hydrostatic force acting on the surface, right? So that's what we call center of pressure, and that is the answer for the first question. And the second question is asking, someone claims that she can determine the magnitude of the hydrostatic force acting on a plane surface submerged in water regardless of its shape and orientation. If she knew the vertical distance of the centroid of the surface from the free surface and the area of the surface, is this valid claim explained? So she is saying, yeah, if she know the centroid and the surface, free surface area, right? Surface area. So if she know the surface area and the centroid, can she find the determiner of the determine the hydrostatic force? Can she determine? So the answer is yes. How can she determine? Let's see how can she do it, right? We know that P is equal to F over A. P is equal to F over A, and hydrostatic pressure is going to be equal to PA. In this case, this is going to be pressure at centroid. So it's going to be pressure at centroid times the area of the surface. So we know this one already. Pressure of centroid. So we have to know what do we need to find the pressure of centroid. To find the pressure of centroid, we need to know the atmospheric pressure that we all know, and then rho, density of the whatever the thing we are trying to find. In this case, this is sea gravity magnetic acting on a plane surface. Water, okay, so it's a water. So we know that it's 1,000 kg per meter cube. So we don't have to worry about it. And G we all know, and HC. If we know the centroid, then we can. If you know the centroid, we can calculate the height, right? So centroid is basically the height. So we know the height of centroid, and then this will give us the pressure at the centroid, right? So we can calculate pressure at centroid, and we know the surface area. Yes, we can calculate the hydrostatic force. So we don't need anything else, right? So C is right. The answer is yes. This is the reason we have all the information, so we can calculate. And that's the answer for this question. I hope you guys like this video. See you next time.